Hey YouTube, it's RN here. I'm down in the control room, and I know last video I shot on my roof, and it's partly cloudy outside. And what I was showing you on the roof, those 24 100 watt panels are coming to this FM60 right here, and it's charging my 48 volt bank. You see the numbers right there. I'm thinking about rewiring it for 6 sets of 4 instead of 4 sets of 6. Because you see the amperage is kind of high coming in. You want to bring the amperage lower. That might cause more heat. But right now, that's what I got coming in. This thing's got as high as 1900, and it'll probably get a little over 2,000. Probably about 22 peak. Those panels are pretty efficient. I've been watching them. I started late fall when installing, I think I got by fall last year. I probably had 800 watts up, and I built off of it all the way till probably November. Got 2,400 total, 2,400. So right now, it's partly cloudy, and that's how much power I'm pulling into that. And this is charging my 48 volt bank. It's used to charge my 24 volt bank. But now, like I said, I switch from there to here, and this runs my dishwasher right here, this power inverter. I strictly click this switch, turn this breaker off right here, and power comes in through right here, to this fuse, to right this switch. And this switch goes from here to this circuit breaker and goes in here on this side. Then I tripped this circuit breaker right here and flipped it the other way, which goes right to this power inverter when I run my dishwasher. So when this pulls in during the day, probably run my dishwasher anywhere from 9 to 10, 11 o'clock. Those panels are probably full light of sun. I take it, and this is a hybrid inverter. It takes the power, charges my batteries, my 24 volt bank, and sends power, the excess power, to the dishwasher. So this pretty much charges my batteries and runs my dishwasher at the same time, still charge the batteries with full sunlight. So when I'm done with it, I send everything right to here, charge my 48 volt bank. This is like the float charging thing. I'm gonna add probably about 400 watts. I gotta replace it, because this one's gonna be maxed out at 230 watts. So what I'm gonna do is replace it with this right here. It's a 520 watt solar charger, and I'm gonna put this one in my car. And this right here does those 30 watt panels. I got, I think, 36 30 watt panels to here, or I can switch it with that switch and pump back to the grid, which now I pump it back to the grid, and I'm getting 863 watts. Those things on my shed and 4 panels on my roof, they're going to this one. This is my washing machine, and it's charging my 24 volt bank. And it's 2,000 watts coming into it. And I'm bringing, right now it's at 2618. It's, let's see here, what the voltage is. 26.9. I gotta figure out, anybody know this answer to this, but it seems like when it gets to 27 volts, it's kind of slows down charging, or whatever. Anybody can give me an answer? I probably got to go internally and program it, or go through these options. I don't know. I got to read the book. I got to take some time. But it's 26.9, and this is what I have coming in. 600 watts. This thing is peaked probably about 1,500, 1,600. Yeah, about 1,700, something like that. So this, I don't know. Right now, I got this solar charge control. I'm still trying to work with that. But it seems like this slows down. So when this slows down, I send everything through this switch to this charge control, and this picks up back up, takes it up to 28.8 or 29 volts. I pump back to when I pump back to the grid between this one and this one right here. I got this is brand new, because the other one of these burnt out. I'll let y'all know these power inverters. I mean, I've had this one for a while, but I had a 1,500 watt one that burnt out. So this right here, this is a grid tie, and this actually does batteries too. You can discharge batteries and send back to the grid at night. And this is 4 Renogy 250 watt panels to a total of 1,000 watts on my shed. This is what I'm pulling in right now. They're pretty efficient. This has gotten as hard as 986. So it's damn near 1,000 watts coming in. I got 8 gauge wire coming in. What I think I'm going to do is, well, I don't know. Let me just hold that thought. But this is coming back to the grid right here. 800, and this is my other panel that's on that little shed on my deck, which goes to this power inverter right here. And I got this. Like I said, I'm still in the construction here, so you gotta mind the mess. I'm sorry for it. Excuse me for it. I ran another circuit in here to add 1,700 more watts, like I told you on my roof. This is 10-3 wire right here. I got it going all the way up to my roof, so I can add the 10 panels on the back and the 5 100 watt panels on the front. And then I'm gonna add additionally with the other red wire, and I'm gonna use the white and the white wire and the ground wire here as a ground, a neutral, and then split the 30 watts on panels to the red and put all the neutrals together, and then the black wire is going to be the other 1,500 watts. So what I'm going to do is use this one to charge the 48 volt bank all the time. This is going to be strictly on the 48 volt. This is a 48 charger, and I think peak that can come into this is 2,080 watts at 40 volts, 48 volts, sorry. So I got 1,500 coming to that, and I'm going to maximize the voltage to, I got calculated to 114 volts, which is probably 110 volts. So everything's going to match my outlet specifications. I mean, probably get it to 120, but this is going to be strictly the 48 volt. These right here, these are the same thing as that, but if I want to at night, I use this for my washing machine, pump back to the grid. I use that 48 volt bank in here. I just click this on right here, this switch, and this comes right off the 48 volt bank at night. If I want to wash clothes at night, I just pump back to the grid. I switch the washer circuit right here to line, and then flip this on, and then it goes right to the grid. This can put out 760 watts at a time. And this one I got on the other leg too. This does 500 watts right off the batteries. So I'm gonna click it off. I use that at night, only at night. Because you all know that we have greedy meters. So whatever we use, we have to pay for. And then I have this right here on the 48 volt bank, which I can also switch circuits from a 24 volt or line right there, or I can switch it the other circuit breaker to come right off of this right here. And this runs off the 48 volt main. This is a pretty good power inverter, 2,500 watts. In my room, we have 2 computers in there. I ran this thing for, I think the computers, at least, I want to say 10 hours, and had this going too. I had it set to somebody put out 150 watts. And my batteries probably went to almost 50%. But it's a pretty good power inverter. It holds up, doesn't get hot. The fans kick on, come off. I got it hardwired all the way to that breaker. And then I can switch right there. It goes into the circuit, or I can switch it to the transfer switch or line through the transfer switch. But it's my little setup. Batteries in here. They're Rolls-Royce 12 volt batteries, 4 of them, wired in series, and they do pretty good. They're 210 amp hour batteries. They work pretty good. And then in here, I showed you in other previous videos. I have 8 6-volt Rolls-Royce batteries that are not 436 amp hours. 2 strings of 4 paralleled to make it 468 ampere hours battery, and until 936 for the 24 volt. And this is the power inverter that pretty much does everything. I can charge the battery banks like in the wintertime. Like I'm doing that right now. I'm charging it, probably putting about 50 amps to the batteries right now, and then using these to pump back to the grid so everything is circulating. It's putting out 852, and this is 781, and then this is I don't know if you can see it, 132. So it's a total of I want to say 17, probably 17 1800 watts. Something like going back to the grid, and this is putting out 50 amps to the batteries. So it's circulating, sending the solar power through the circuit breaker, and this is sucking it right off that circuit breaker to here and charging my battery. So circulating, just, you know, protect my batteries, you know, sunshade, whatever. I need a constant charge on the batteries. So I'm getting using as much solar as I can to help this out. I'm gonna, when I get all this other stuff hooked up, like I said, I'm still in the construction. I'm gonna straighten all this out, but you know, this is my testing phase. This is what I got so far, but I'm gonna do another video when I get this hooked up. I got this circuit ran in, got to put the other panels on my roof, and then that'll be it. Then I should be able to get my bill down to $20, $50 at the most, to nothing. And just use, I've calculated everything here, using the dishwasher one time, and at least using the washing machine or the dryer and everything according to, I only get 4.2 hours of sunlight here. So that's why I have so much power. So I gotta be able to manage it. If not, it's just gonna go to waste. So that's why I got all these circuits. So I have to kind of be down here. Hopefully I can get it to an automated system. But this is what I got so far. So thank you for watching. It's RN. I'm out.